Common trajectory prediction, European perspective. Of course, we're here to sell our own goodies and to get the maximum of intellectual baggage away from you as is possible so that we can reduce our own cost. What are we going to talk to you about with my colleagues? Evolution of ideas, vision and concepts. If you don't have a vision and a concept, you're not going to get money. So we have to pay lip service to those people who develop those things. Common trajectory prediction, as already Steve indicated, is a main issue for us. But it's a big problem because it is not sexy. It does not have a human interface that you can show. There are no big color things. You don't see it anywhere. So if you don't see it, it doesn't exist. Still, after having, thanks to the introduction that you gave, you know that I've already been in this business for 30 years, and the fact that I talk about trajectory prediction means that there was actually no point for you to come here, because if you haven't succeeded to solve the problem in 30 years, then what the heck are we going to do then? But there is some lessons learned. Maybe there's a way forward. We must have a way forward because we have to feed our families. And then practical deliverables. Those are the things that actually will be presented by my colleagues Carlos and Eric. And as you see, the major part is reserved for the one who has nothing to say. But I have to be politically correct, but I don't think there is a large difference in your organization and our organization. So, evolution of ideas, vision and concepts. Like you, we have lots of vision and concepts. Today we're implementing eChip 3. I do not remember anymore precisely what it is, but it is a concept that has been developed by controllers for controllers. What went before? Before we had FAR, maybe some of you remember that. That was a concept developed by engineers for engineers, and that failed. Where we are now with eChip 3, of course, developed by controllers for controllers, that failed as well. I will tell you why. This doesn't stop us, but now the industry said in Europe, this is our time to come. So the engineers failed, the controllers failed, here industry comes. Collaborative or cooperative air traffic management. Deployment, 2012, and we aim here at multi-sector planning, strategic AGM, all these things. But what is more important, I think you will hear a lot about that, is Sesame. The initiative of the European Commission, that's what they say. Actually, Sesame was an unsolicited proposal by European industry to the European Commission in order to tap off their money funds. 2020 implementation, and it's going to improve the ATM world. After this, I guess we go back to the ATM concept for engineers by engineers. So the whole circle is around again. The French have said this already often, l'histoire se répète. But one thing I think we can learn already, and that is that we try to improve the role of automation in ATM. Try. CATM, quick overview. It's a consortium of 22 European partners in 8 nations. And it's led by one of the major European air traffic system developers, Thales. The buzzwords, no project, no money. CATM will deliver, save, synchronize and separate the flow of traffic, and you see the things that you have seen a lot yourself. How do we do that? Of course, we have a good plan and a solution for that. Synchronization and tactical control, cost controllers will still be there. Again, the standard buzzwords. And on the tactical side as well, we develop a plan and we ask the controllers to do the plan. But the interesting thing is, and remember, CATM aims for implementation in 2012. It will be heavily based on airborne separation assurance, spacing, sequencing and metering. How we get there, that's a different story. Sesame then. Single European sky, implementation program for that, unsolicited proposal by industry, money coming largely from the European Commission. The driving for that was what I already indicated and what I'm a little bit ashamed of why I'm here. We have not really improved a lot from 20 years ago. Yes, we changed from round screens to square screens, where the square screens today have a little bit less resolution than the round screens that we have, but at least we can generate now with less resolution the same green color. Technology is available. This is what we engineers try to convince to our controller friends, but they don't want to use this for unknown reasons. But one thing that is true, so mind you, those are the slides that I've picked off an official presentation of the European Commission. This is not my vision. So these are the slides of the European Commission presentation. Decision making is weakness in ATM. I guess we all agree. If not, that's for the questions and answer. Here are some objectives where I think the important thing is that as Europe is united now, we don't have a constitution, but that doesn't stop us. We are going to develop for you one vision shared with the world. It doesn't say sold to the world, it's shared with the world. So in principle, you get it for free. What is interesting now is that if I compare this with a presentation that I picked off the internet done by Robert Pierce on the GPDO, the GPDO has, let's say, summarized the ATM problem in the US in a somewhat packed way. One of the ATM problems in the world is a serious challenge to US leadership in the global aviation market. I didn't know that that was an ATM problem, but these are the three key things. But Sesame is we're going to do everything for the world and we're going to share it with you. And I think the GPDO perspective in that respect is right, because it's a serious challenge to your leadership. So I think we have something to share. And this is one of the reasons why we're here and we are a happy team. Oh, we look happy, but of course, we have a we're working on a memorandum of cooperation with the FAA, with China, of course, because it's cheaper to get things there. And that's an interesting thing, Sesame will be open to non-European industry. This is the message to Boeing: we will let Boeing aircraft fly in European airspace. Seriously now. In the present ATM system, we have ground systems and air systems. And on the ground, we have trajectory predictors everywhere. The more manufacturers you have, the more trajectory predictors you have. Unfortunately, the more aircraft manufacturers we have and FMS manufacturers we get, the more trajectory predictors we get there. All these trajectory predictors generate trajectories. And if you want to have a safe and efficient system, the problem for us in the ATM world is how do we get consistency between all these things? And this is one of the main challenges for our team. But as you can see, it is the problem is relatively in the center of the system itself. So nobody of our management is really interested in this part. Trajectory predictions process. Lots of you have heard about SWIM and flight object and all these great ways to move flight plans from one place to another and get to the same thing, but what does it help us? In any case, what we have to say is that the trajectory, the data that we have in SWIM will be the key input into the trajectory prediction process. And there are two key elements in there. Sorry to bother you with technical details. It will get worse when my colleagues get here. We have a flight script that describes exactly, or as exactly as possible, what the aircraft is going to do, and we have a trajectory engine that integrates that information into a trajectory. And of course, there I do not know what I've done here, but this is what I wanted to do to get a predicted trajectory. However, what you need is an aircraft performance model, and you need a meteorological model. That gives them a beautiful picture. As we have seen that trajectory predictors are everywhere, it would be a logical way, because our management, in this case I have to say our management, says that if we have one place where we predict the trajectory and we simply distribute it everywhere, then we do not need any more trajectory predictors, and the problem is solved. So is that the case? Well, sharing the same trajectory does not mean sharing consistent information. Because if we generate with the same trajectory information, let's say the same intent information and the same aircraft performance model trajectory, it does not mean that we get the same trajectory if, for instance, the meteorological model that is used is not the same. So, same flight script does not result in the same trajectory. Reason for that is, imagine that you have different ground-based systems with different meteor models, different FMSs. Every FMS and every aircraft has its own meteor model. So even if you would share the same intent information, that's the information that goes into the trajectory predictor, you will not get the same trajectory. Consistency of information can also be distorted by the presentation of the trajectory. If we look now what comes out of the FMS on the 702A, I said it correctly, 702A bus, we see that the trajectory there consists of straight segments and fixed radius turns. Today, let's say the major part of the aircraft are not capable of flying fixed radius turns. So even if you would downlink all the trajectory information that is available in the FMS, on the ground you would have a non-realistic representation of that trajectory. So there is still work for us to do, and it is not that simple, downlink the trajectory on the ground and off you go. Performance requirements for trajectory predictors. If we work on trajectory predictors, we should work on the basis of performance requirements that allow us to tick off if we have met the objectives. If we ask, who are our clients? If I say we, let's say trajectory predictor builders or people that work on it, who are our clients? In principle, those are the decision support people, the people that build decision support tools. There is no problem with that. If we ask them, what are your requirements for trajectory prediction? We get simple, straightforward answers. The for free, of course, that's from the Dutch trajectory builders. That's the obvious thing. Actually, we don't really worry too much about the other things. If it's for free, it's okay. Current implementation of that is the Egypt 3 implementation in Europe, looks at improved sector productivity. The support tools that we have are conflict probes, monitoring age, basic arrival management. And the difficulty that we see with those people is that, now let's say, the technology that they use in these tools is actually you build a volume of protection around every aircraft, and the moment that those volume of protections overlap, you have detected an issue. The problem is that those volume of protections increase in size when the look-ahead time increases. And already in 1997, our friend Adrian McGill from DERA at the time, DERA does not exist anymore, but Adrian still exists, did a fast time simulation and say, well, what type of performance can we get out of a conflict probe if we would use the best trajectory predictor we can ever build? And these information have been confirmed by other studies done slightly in different contexts, and the results is presented in a different way. But if you look at this, these results, so this is the best trajectory predictor you can ever build, and actually from all the results that we know, in particular the results done by the Tech Center here, we know that in fact the actual uncertainties are a factor 2 larger. We see that conflict probing for strategic planning with a 20-minute look-ahead time is not feasible. And this is why industry has come up and say, well, okay, we start Sesame now because this is going to lead nowhere. The result of this eChip 3 concept now is that in Europe we have in quite some national air traffic control centers the latest versions of ATM systems installed with conflict probing facilities targeted for strategic planning, which have been switched off because they don't work. And already in 1997 it was predicted by an engineer, but which controller listens to an engineer, that this would not work. But all problems will be solved in the future. We have lots of places where we build trajectories. We have lots of places where we communicate information. We are very good in that since internet is there. We can even communicate between aircraft. But as Mike already indicated there, if we don't have a common trajectory knowledge, we have safety and efficiency issues. So we should do something about it, and this is why we have AP16. What are our major problems? Our major problems is that all these individual manufacturers are convinced that they have the best trajectory predictor in the world, and because of that there is no reason to share the information that is the basis of their product with anybody else. Like Steve from NASA Ames believes that his trajectory predictor is the best one in the world, or his colleagues think. But I can tell you, this is pure shit. Because we have the best. So you imagine if you really want to have fun, come and join us in the meeting because we have really a great time there. But it is a major issue. How do we break open the castles that exist? How can we convince our management that we need political backup and support to do something about this? That's a real problem, and we haven't solved this yet. So, I mean, doing technical work, that's nothing, but taking down those walls is a major issue for us, and we're still working very hard on that. So, sorry to have bothered you for such a time, because now the real gurus come on the place, because the fact that I have nothing to say doesn't mean that I have to shut up. Huh? US and European visionaries have identified similar issues. These are your GPDO or Sesame and all the things. Fortunately, we have challenging targets. That's good for our families and our kids' children. We have to build automation, but so far that I'm in the ATM business for 30 years, we have not really succeeded very much. But that's due to my stupidity. The new generation will do a better job. Trajectory prediction is the key enabler. If we don't do that, there will be no automation. That's what we are convinced of. And the good thing is we're really working together now. It's a great pleasure to work with this team. It's a great pleasure to work with Mike, with all the experience that he has and the openness that the FAA gives towards us, and we try to reciprocate that.